Welcome to CSEGURU. In this session, we will discuss the topic Introduction to Recursion. The next topic under Stack Applications. What is recursion? Definition. A recursive function is defined as the function that calls by itself. Any function or any user-defined function, if it calls by itself in the sense, that is called recursive function. What is the purpose it has to call by itself? It has to solve a smaller version of its task until a final call is made which does not require a call to itself. That is, you will divide the given problem into its smaller versions until, how long you have to divide it into smaller versions? Until a final call is made. That call, that is the final step which does not require a call to itself. For example, if you are considering a problem of size n, if you want to find the solution for this n size in the sense, divide the problem into n minus 1, n minus 2, n minus 3. Likewise, you have to divide it into smaller versions until the final call you will reach it. That is the final step you will reach it. That final step does not require a recursive call. Until that time, you have to divide this problem into its smaller versions. Okay. Then find the solution for n minus 1, n minus 2, n minus 3. Likewise, for all its smaller versions, you find the solution, and if you are combining all these solutions, you will get the main problem solution. And this main problem, how we are getting in the sense, by recursive call only. What is the C code you have implemented for n? The same code will be implemented for n minus 1, n minus 2, n minus 3. With the same code only, using this recursive call, we will solve this smaller version, again this smaller version, again this smaller version, until you will find the last step where it does not require recursive call. Until that time, you have to divide it into smaller steps. So this is nothing but recursive function. So simple definition for recursive function is any user-defined function calls by itself. It is called recursive function. And here, since a recursive function repeatedly calls by itself, the function calls by itself, it will make use of the system stack. One of the main application of stack data structure is recursion only. Okay, so here the recursive function, it will be implemented repeatedly by calling the same function itself. So here it will use the stack data structure to store the return address and its local variables temporarily. And here in recursive function, we will use two major cases. One is base case, another one is a recursive case. So what do you mean by base case in the sense? Here the problem will be solved directly without any further calls. That is, for this base case, recursive call is not required. Okay, for this base case value, if you want to find the solution in the sense, recursive call is not required. For example, in factorial function, if you are considering in the sense, if n value equal to 1 in the sense, it has to return 1. Value 1 as the result, it has to return. If n value was 1 in the sense. So this is the base case. If n value is 1 in the sense, no need of any recursive call. Directly it will return the result as 1. The problem solution as 1. This is called base case. So base case does not require recursive call. And recursive case, if you are considering in the sense, the given problem will be divided into smaller subparts. That is, the smaller version of its problem, you have to divide it. And however possible, you have to divide it. Okay. Then the function calls itself with the subparts of the problem. That is, for every smaller version of the problem, if you want to solve it in the sense, the recursive call is required. That is, the function calls by itself. Third, the result is obtained by combining the solutions of the simpler subparts. Okay. The recursive case, if you are considering in the sense, three main steps here. First step is divide the problem into smaller versions. Second step is for each smaller version, implement the recursive call to find the solution. And third step is combine the results of the smaller problems, you will get the solution for the main problem. Okay, this is called recursive case. So base case in the sense, for the smallest value, for any problem, if you are solving the smallest value in the sense, in that case, recursive call is not required. And the recursive case, when it is required in the sense, when the problem size is bigger. Okay, directly you cannot able to solve the problem in the sense. In that case, divide the problem into subparts, find the solution for the subparts using recursive call, then combine the solutions of the subparts. Then you will get the main problem solution. Okay, this is called recursive case. So two major cases in recursion in the sense base case and recursive case. And this base case and recursive case, how we can able to implement with the factorial function, that we will discuss. So recursion, if you are considering, it is defining larger and complex problem in terms of smaller and more easily solvable problems. Okay, so here initially larger and complex problems will be given. This problem, larger and complex problem, will be divided into smaller subparts, and each subpart you will find the solution using recursive call. Then you can able to solve it easily. Instead of solving directly the larger and complex problems, it is hectic. Okay, instead of that, you will divide it into smaller parts and solve it. Okay, that is the main advantage of recursion. So in recursive function, the complex problem is defined in terms of smaller problems, and the smaller problems will be given explicitly. You are going to find the solution for the smaller problems only explicitly, not directly the complex or larger problems. Okay, for example, calculating the factorial of a number. If you want to calculate factorial of any number in the sense, here the factorial function will implement the base case as well as the recursive case. So base case in the sense, whenever n value is 1, when n value is 1 in the sense, this is the simplest value to find the factorial function. When n value equal to 1 in the sense, this is the smallest value. This value does not require any recursive call. Okay, in that case, this comes under base case. So when n value is 1 in the sense, result will be 1. How about in the sense, 1 factorial value is 1. This is a default value they have given for 1 factorial. If n value is 1 in the sense, this function does not require any recursive call to solve this problem. Directly it will return 1 as a result. That is the base case. And recursive case in the sense, for example, if n value is greater than 1, they have given in the sense, in that case, the base case we cannot able to implement. Directly we cannot able to find any value. So if n value is greater than 1 in the sense, in that case, how we will find the factorial function in the sense, that is n into factorial of n minus 1. For example, if n value they have given 3 in the sense, how we will find in the sense, n value is 3. Okay, so 3 into factorial of 3 minus 1 is 2. Again, with this value of 2, again the recursive function factorial is called. Okay, then in the next is recursive call, how it will implement in the sense, for this factorial of 2, this is n into factorial of n minus 1. What is n here? N you have to consider as 2. So 2 into factorial of n minus 1 in the sense, 2 minus 1 is 1, you will get it. So factorial of 1, when n value is 1 in the sense, that is the base case. N value is 1 in the sense, 1 factorial, result is 1 only. Next recursive call, if you are implementing with n value 1 in the sense, you will get result 3 into 2 into factorial of 1 in the sense, implement value 1. So you will get it as 6. This is the result of this factorial function, n is equal to 3. Okay, so here when n value is 1 in the sense, directly it will return 1 as a result. When n value is greater than 1 in the sense, implement this formula using a recursive call. See, the user-defined function is factorial of n only. Okay, the function calls by itself. So every recursive call, the function calls by itself. That is called recursive function. The best example is finding the factorial function. And here this is the C program to implement the factorial function. So here number and value have to declare as integer. So the number you need to enter. This is the input to this factorial function, that is nothing but n value. Number I will give input as 5. Okay. So here value equal to factorial of number. This is the user defined function and this is nothing but function call. So once the function is called, what is the number value? It is 5. So with n value 5, the function is called here. Once the function is called, control will be transferred to its corresponding user-defined function. So here how it will implement, int fact of int n. N value, it will consider the number value, that is 5. If n is equal to 1, condition fails. N value is 5. So it won't implement the true part. It will go to else part. It will return. So here I will write down, it will return n into, that is, this is the first recursive call. n into, what is the n value? N value is 5, okay. So n is 5 here, n into fact of n minus 1 in the sense 5 minus 1 is 4, you will get it, okay. Again, with this value 4, again the recursive call is made here. Now it will consider n value is 4. It will come and check it. Whether n value is 1, condition fails. It will go to else part and again it will implement the concept. So here second recursive call, it will implement 5 into, with the n value 4, it will implement the formula n into fact of n minus 1. N value is 4 now. N into fact of n minus 1 in the sense, it will consider it as 3. Okay, with n value 3, again the recursive call is made. So here n value will be 3 now. Okay. So third recursive call, if you are considering, it is 5 into 4, already it is there. And this is the user defined function calls by itself. So fact of n value is 3 in the sense, it will come and check it whether n value equal to 1, condition fails, it will go to else part. And here it will return n into fact of n minus 1. For this fact of 3, with the n value 3, n is 3 into fact of n minus 1, 3 minus 1 is 2. Again the recursive call is made. So here fourth recursive call it will implement. So here already 5, 4, 3 it is there, and here this function again it calls by itself. This is a recursive call with n value 2. It will check it whether n value equal to 1, condition fails. It will go to else part and it will return n into fact of n minus 1. N value is 2. Here it will consider 2. 2 into fact of n minus 1 in the sense fact of 2 minus 1, value is 1. Now n value is 1. Now again fifth recursive call, already this is there, 5, 4, 3, 2 it is there, and the recursive call it will made it here, fact of n value is 1. It will check it if n is equal to 1. Yes, condition is true now. If it is 1, it has to return 1 as the result. So here for this recursive call, result is 1. It is the smaller version. Okay, the main problem is n is equal to 5. So here every step it will consider, it will divide the problem into its smaller version and it will try to find the solution for its smaller version. Finally, if you are combining these solutions, this is the first recursive call solution, second recursive call, third recursive call, fourth recursive call and fifth recursive call. So if you are combining all these 5 recursive call solutions in the sense, you will get the main problem solution. So what is the result? You will get it 120, you will get it. So when n value equal to 5 in the sense 5 factorial value is nothing but 120. So this is the result of this factorial function, and this factorial function we have implemented using recursive function concept. Okay, factorial function is the best example for recursion. And next, steps to implement recursion. So whenever you are implementing a recursion for any problem in the sense, what are all the steps you need to follow? So first step, if you are considering in the sense, specify the base case, which will stop the function from making a call to itself. So for solving any problem using the recursion concept in the sense, you need to specify the base case first. For example, factorial function. If n value equal to 1 in the sense, it has to return 1 as the result. Okay, it has to return 1 as the result. This is the base case in factorial function. So first step is, for every problem you have to specify the base case, and this will avoid the further recursive call. Step 2. Check to see whether the current value being processed matches with the value of the base case. If yes in the sense, process and return the value. First you need to specify the base case, and once the problem is given, check that problem, and if the problem input that matches with the base case in the sense, process and return the corresponding result. For example, here n value is 1 in the sense 1 factorial, it has to return 1 as the result. This is the base case. Next step, suppose if the given problem does not match with the base case in the sense, divide the problem into smaller and simpler subproblems. However possible, divide the problem into its smaller versions. Then step 4, call the function for each subproblem. The function calls by itself. Call the function. Here the concept is recursive call will be made. So implement the recursive call for each subproblem and find the solution. Then step 5, combine the results of these subproblems. Each smaller versions, you will find the solution using recursive call, then combine it. Okay, then return the result of the entire problem. You will get the solution for the given problem. Okay, simple steps. First step is specify what is the base case for that problem. Second step is for the given input, check whether it matches with the base case. If yes, in the sense, return the proper value. Step 3 is, if the given input does not matches with the base case, in the sense, divide the problem into its smaller versions. And step 4, using the recursive call, find the solution for its smaller versions. Step 5, combine the results of the smaller versions. Step 6, return the result, final result. So for any given problem, if you want to solve using recursion, in the sense, you need to follow these steps. That is the common steps to solve any problem using recursion. So this is all about the basic concepts of recursion. So next session onwards, we will check some more examples using recursion. Thank you for watching this video.